Hello, I'm Tom Robertson. Today I'm going to be talking about managing the risks of artificial intelligence. Talking about this from the perspective of what can we as emergency managers do to mitigate the threats posed by artificial intelligence. Many of you may be familiar with artificial intelligence as a source of tools in emergency management, and there are plenty of those, and they're continuing to be developed. However, what I'm going to be focusing on are the risks of artificial intelligence and the potential ways that emergency management can help mitigate those risks. Of course, AI has been very much in the news lately. Many of you have seen headlines and read articles about ChatGPT passing college exams, AI being used to create art, often without permission from the artist to provide the original source material, job disruption, biases in AI tools such as automated facial recognition used for law enforcement, use of deep fakes to influence and potentially thwart democracy, artificial intelligence being used to control infrastructure and creating vulnerabilities, the threat of lethal AI weapons in warfare, and we even have AI experts now warning of the potential for human extinction if we don't control the use and the development of AI technologies. Before I talk about where we are today in AI, I'd like to give a little history. In 1943, McCulloch and Pitts developed a very simple model of the neuron, which is a building block of the human brain, and showed that by connecting enough of these simple units together, they could do complex mathematical calculations. In 1951, Claude Shannon developed a mechanical mouse that could navigate a maze, starting and learn to do the maze, starting from any point in the maze, based on interconnection of mechanical relays that implemented very simple Boolean algebra. In 1955, Arthur Samuel developed a program to play checkers, and he programmed it so that it could play itself and improve its performance. Eventually got to the point where it could beat him, showing the first glimpse that human beings can create programs that can outperform them in some ways. In 1982, Digital Equipment Corporation took advantage of another form of artificial intelligence called expert systems to create a system that would support their customer engineers in configuring particular systems. And they estimated they saved $25 million with that. 1997 was a big year when Deep Blue, which was a computer system developed by IBM, beat Garry Kasparov, the chess champion. Headlines at that point were, when are machines going to be taking over? Sounds reminiscent of what's going on today. The Defense Advanced Research Projects Agency has always been interested in AI, and one of their programs was called the Grand Challenge, which created the technology that forms the basis of today's self-driving cars. In 2011, another IBM creation, Watson, won Jeopardy using a combination of AI-based techniques. And then finally, in 2017, a program called AlphaGo defeated a championship Go player, surprising quite a few of us because Go is more complicated than chess, many more possible moves. There are people that, and still it was able to not only defeat the best player, but also eventually achieve performance beyond any human. The breakthroughs in artificial intelligence today are based on deep neural networks, which is a very large version of some of the early artificial neural networks that were at the very beginning of artificial intelligence. Basically, these deep neural networks are numbers in, numbers out. And in between, there are these huge networks of simple elements that perform calculations to produce outputs based on inputs. Now, this is all useful because engineers have figured out how to take things that we're interested in recognizing or interpreting and turning them into numbers that can be used by deep neural networks. So, for example, these input ones and zeros could represent a query, a voice query. It could represent a scene being sensed from a self-driving car. It could represent text. It could represent the stock market. So these first have engineered transitions to put them into numerical form. They're processed by the neural network, and then they produce numerical outputs that then can be interpreted into something useful. For example, a frame-by-frame recognition of the objects seen by a self-driving car, identifying the bounding boxes of the vehicles, and identifying their type. Deep neural networks are very complex. Fortunately, much of that complexity is handled by a technique called machine learning. Through machine learning, training data is used, sometimes millions or billions of examples, and a mathematical optimization technique is used to score the performance of the deep neural network as it looks at the training samples and adjust millions or billions of parameters until the deep neural network gets the right result. So basically, everything that the deep neural network learns, it comes from training data. ChatGPT is an example of a large language model, a particular form of deep neural network. A large language model can take a string of text, such as write a paragraph on protecting critical infrastructure, and produce an appropriate output. It does this by numerically encoding the input and by learning through its training process to produce the desired output. Let's talk about the risks associated with using AI. The first risk is failure in novel situations. This is an example where a self-driving car struck someone who was walking a bicycle across a 4-lane highway late at night. Because this situation hadn't been encountered in its training data, the self-driving car did not recognize this as an obstacle to be avoided. Another problem is bias. For example, in law enforcement, if facial databases used to train automatic facial recognition systems contain a large percentage of people of color, it can make biased decisions in assessing the risk of an individual. As infrastructure is being controlled by AI, it's a great tool to do that. However, those sorts of tools can become vulnerable, such as this case of the Colonial Pipeline that was subject to a cyber attack that disrupted fuel delivery through much of the East Coast. During war, AIs can make systems more lethal, and they can leverage the lethality of terrorists as well. Because AIs can produce convincing text, deep fakes, they can be used on social media to influence and create polarization. They also can be used for surveillance, creating problems with privacy. And then finally, disruption in employment through the use of AI tools, particularly now with the large language models, and white-collar workers will be displaced. This creates problems not only for individuals, but for communities, and can create unrest. Emergency managers can support the mitigation of AI risks along several dimensions. The emergency management community has an influence and actually works in several stages throughout the deployment of AI systems, including administration, operations, engineering, and research. So what can we do? Well, on the administrative end, we can influence policy, laws, and standards that control the use of AI and ensure that proper safeguards are taken. We can also look at safety protocols and procedures, help define those and put them in place in our various areas of concern. Exercise and rehearsals have always been an important part of emergency management planning. We can incorporate failure modes of appropriate AI systems in these exercises and rehearsals and use those to better prepare ourselves, our communities, and to improve the safety protocols and procedures. Some of us are involved in engineering systems, and we can help engineer systems, some of them using AI themselves to be watchdogs that can help circumvent, detect problems that are associated with AI systems that are playing a role in our societies and infrastructure. And then finally, those of us who are in a position to perform or influence research can help develop AI systems that are inherently safe within their operations. To some degree, this is being done with large language models such as ChatGPT, where humans in the loop help weed out some of the most egregious behavior. Finally, let me conclude. AI is finding increasing use in our communities and societies. It carries risk with it for failure, unintended consequences, and malicious use. As a community, emergency managers can participate in mitigating these risks by helping to create policy laws and standards, helping to develop mandate safety protocols and procedures, simulating AI failures in exercises and rehearsals, better preparing ourselves, helping to engineer safeguards and alerts into our systems, and influencing research to incorporate inherent safety into AI systems. Thank you very much.